Welcome to Skill 4. This is all about using a graphing calculator to find key points in our polynomial functions. So, notice we are given, I don't want my green highlighter, we are given this particular function and asked to find each real zero to the nearest hundredths and state the relative maximum or minimum, if they exist. So let's go to our graphing calculators and let's see if they exist, and we'll write them down. So when you get your calculator, whether you're on the extension for your Chromebook, or if you have a calculator, go ahead and turn it on in the bottom left-hand corner. And we need to put that function into our y equals so we can graph it. So upper left-hand corner, go ahead and put in y equals, and you can see that I actually have an equation in here. So on the right-hand side, I'm going to hit clear, and it will go away. Now, if, for whatever reason, you maybe have your plot highlighted, you need to arrow up, press enter, and unhighlight it. What that means is your calculator is going to search for data so that it can graph some sort of statistical representation of the data. Box and whisker plot, scatter plot, and so forth, and we are not giving it data. We are, however, going to put in the equation 2x is up here underneath mode, and then you can either do the little upside down caret for the cube and then make sure you arrow over to get out of that exponential spot, or you can hit math, which is on the left-hand side, and notice right here, the third one is the cube, so you can just hit that and it'll automatically cube it for you. Plus 6x squared, and squared is on the left-hand side to the left of that comma. And then we have minus 14x plus 12, so plus 12. And go ahead and hit graph. Now, if your window has been adjusted, at the top there is a zoom button, it's at the top center. 6 will always reset your window. So if, again, your window is a little bit adjusted, we'll say, you can always go back to standard. Now, I know that this is a cubic. It has a leading positive coefficient. So my end behavior is down to up. I do see that there's going to be some sort of a turning point up here, and I'd like to see it. So I could either zoom out, or I could force the window of my calculator to go where I want it to. How do I do that? If I click window, my x minimum and my x maximum are fine. That means that the x-axis goes from -10 to 10. X scale, every tick mark is 1 unit. I'm good with that. The y max, however, I need to change a little bit so I can see more. Now, I'm just guessing. I'm going to put in 35 and hit enter. And then I'm going to hit graph again. And oh, yep, I can see a little bit better where my maximum, my relative maximum, and my relative minimum are going to be. Well, first it says to find the zeros. We only have one. Okay, we can see here that it's only going to intersect the x-axis one time. Remember that because its degree is a 3, it's a cubic function, it could at most intersect 3 times, but we only have one, and that is all right. I'm going to hit second trace, and as we go through this, please write down calculator keystroke reminders to yourself, okay? And I'm going to search for the 0. Your x-intercepts are your roots, are your solutions, your zeros. So I'm going to search for the 0. And my calculator is going to ask me to set a left boundary. So I'm going to have to arrow. Here's my cursor right here. The location of my cursor is always at the bottom of the screen. I'm going to arrow to the left until that cursor is to the left of the 0 of the x-intercept. And then I'm going to press enter. My calculator is then going to ask me for a right boundary. So I just need to be above it, and I'm going to press enter. Above it because that's to the right of where that x-intercept is located. It then asks me with these arrows and these dashed lines, is this the area that you want me to search in? And I'm going to hit enter one more time to execute. And it says that it is at approximately -4.74. Now, you might be asking yourself, why does she say that? Because this is not a 0. Well, what this is on the right-hand side for my y-coordinate is scientific notation. negative 1.9 times 10 to the negative 11th power. So really, this is 0.000000000019, which is the calculator's best approximation for 0. It got as close as it could. All right, we are also asked to find the relative min and the relative maximums. So I am also going to hit second trace for the calculator function. And let's go ahead and search for the maximum first. Maximum is number 4. And I can see that the relative max is going to be right up here because that's where my graph has a turning point that changes from increasing to decreasing. So I need to, again, give my calculator a left boundary. Yep, I'm to the left, so I'm going to hit enter. And then I need to move to the right of where that turning point is. So my calculator has an area in which to search. I see my cursor again, so I'm going to hit enter. Calculator asks me, is this where that relative maximum is located? And I'm going to hit enter to guess yes. So the maximum, and I'm writing this down with you guys, hopefully as you are, is located at approximately negative 2.83, comma 54.34. The last one that we were asked to find was that relative minimum. So I'm going to hit second trace again, and I'm going to hit number 3 for minimum. And then notice I don't see my cursor. It's okay. It's located at these coordinates. So it's way up here. I'm going to arrow to the right until I see my cursor and I can verify it's to the left of where that minimum is. And it is. So I'm going to hit enter. And then I'm going to move the arrow so that it's to the right. Doesn't matter how close or how far. Okay. The closer you are, the less scientific notation it will have to use, but honestly, it's okay. You're still going to get an accurate representation of the location of that point. So I'm going to hit enter. Is this where you want me to guess? I'm going to hit enter one more time because it is. And that is located at approximately 0.83, comma 5.66. And the reason I'm rounding out to the hundreds is because the directions on example number 6 told us to, and so we did. Okay, so I wrote it down on a little post-it when we were doing it, but just to go over our zeros, 0 was negative 4.74, and it is an x-intercept. The relative minimum we found was at 0.83, comma 5.66. And the relative maximum was negative 2.83, comma 54.34. So please make sure that you did write down your little keystroke reminders as needed. And example 7. This is a good one. Okay, what are 3 consecutive meaning one after the other, even integers? Okay, we're looking for 3 consecutive even integers whose product is multiplication, is 4 times their sum. Okay, well, let's deal with this piece by piece. The first part, 3 consecutive even integers. So let's call the first integer x. Okay, the second consecutive even integer is 2 away from that, because think, if we've got 1, 2, 3, right? Consecutive integers, they're one step away from each other. But if we needed to have even integers, it would be 2, 4, 6. They're 2 spaces away from each other. So that's why we'll have the x plus 2. And then our third integer, even, would have to be 4 away from the first one. Sweet. Okay. Now, the second part is whose product. So a product is the result of a multiplication problem. So we have x times x plus 2 times x plus 4 is, always means equals to, 4 times their sum. Sum being addition. If you need to, write down plus, equal, what did I say, plus? Multiplication, equal, multiplication, plus. There we go. So x plus 2 plus x plus 4. All right, here we go. First thing I'm going to do on the left-hand side is distribute the two binomials. Please do not try to multiply everything at the same time. You could distribute the x, and then you could distribute that result, that product, into the next binomial. That would be fine. My personal choice, I am going to multiply these two together and leave the x on the outside. So I get x times x squared plus 6x plus 8 is equal to 4 times, well, we have 3 x's, and then 2 plus 4 is 6. All right, now I'm going to distribute the x inside. So we get x cubed plus 6x squared plus 8x is equal to, let's distribute the 4, 12x plus 24. Woo! Look at what we got here. It's a lot of good polynomial stuff we got going on. Go ahead and with me, please, set it equal to 0. We can't solve if it's not equal to 0. So we get x cubed plus 6x squared. Subtracting the 12 to both sides, we get minus 4x minus 24 is equal to 0. Now, at this point, you are more than welcome to throw it into your graphing calculator and see if where the zeros exist, because we're setting it equal to 0. So we're solving for the x-intercepts, for the solutions, right? Well, I see that it's a polynomial with 4 terms. Before I use our calculator, I want to try to factor by grouping and see if that will come up with our solutions. Always with a polynomial of 4 terms, you have that option. So it's the first greatest common factor is x squared, and we're left with x plus 6. And then the second greatest common factor is, negative 4. Yes! And we're left with x plus 6. These are the same binomial. So it worked. I can factor that out, and I get x plus 6 times x squared minus 4 is equal to 0. I'm running out of room. Let's go over here. So then we have x plus 6 is equal to 0, which means that x could be negative 6. We also have x squared minus 4 is equal to 0. I'm going to add 4 to both sides. So we get x could be plus and minus. I jumped ahead of myself, huh? Plus and minus 2. We have 3 options. Now be careful, it doesn't say even positive integers. It just says consecutive even integers that satisfy the condition. Well, here we go. So the first scenario could be negative 6, and then the next consecutive even integer would be negative 4, and then negative 2. The next possibility would be negative 2, and then if you're thinking, how in the heck is she coming up with this? Remember, we set them over here, first one, and then add 2 and add 4 from the original. So that's all I'm doing. Negative 2 plus 2, the next consecutive even integer would be 0, and then 2. And then our last possibility would be 2, 4, and 6. So there are 3 possible scenarios where 3 consecutive integers have a product that is 4 times their sum. And that's it. If you had graphed it, you would have found that this cubic intersects the x-axis at negative 6, negative 2, and 2.